Each spacecraft must start its journey from a launch pad somewhere on Earth. The location of these launch sites depends on various factors, including geography, political issues, and transportation. The most important launch sites have virtually become cities equipped with various components, including preparation, service, launch, and ground guidance of spacecraft. For a spacecraft to be able to reach space from Earth, it needs any help that can be provided. Most launchers are built close to the equator and within a country's borders. These locations give the projectiles the advantage of increasing their launch speed with the help of the ground rotation speed. Finally, the spacecraft orbits in a low-altitude orbit. Launch bases based on higher latitudes are mainly used for satellites that are supposed to fly over the polar regions. Finding a suitable place to build a space launch base becomes more difficult with the introduction of elements such as the need for access and convenient ground routes, and safety considerations. For added security, they try to build these bases where there are no residential areas under the spacecraft's flight path to minimize damage in the event of an accident during launch. Cape Canaveral Space Center. The world's most famous collection of space launches is located on the Atlantic coast in the state of Florida. It is known as Cape Canaveral. It is located east of the ocean and hosts NASA's Kennedy Space Launch Center and Cape Canaveral Air Force Base. Both have seen space flights many times. The airbase was the site of manned spaceflight until 1967. Still, many unmanned space launches are launched from the origin of this center. The Kennedy Center opened in 1962 and has been used to launch the famous Apollo missions and more than 100 space shuttle flights. The center's facilities include several hangars to prepare spacecraft and missiles, which either enter the center by plane or are transported to the center by sea and ship. Baikonur Space Center. Baikonur, Russia's main space launch site, is currently the world's most significant space launch complex. The center is located in a desert in Kazakhstan. The center has been operating continuously since 1957. It has been used for historic launches such as the Vostok 1 in 1961, the first manned space flight in history. Hundreds of kilometers of roads and railways connect the center to rocket and spacecraft factories in Russia. After the collapse of the Soviet Union, the center is run by the Russian Federation Space Agency. The center has also hosted commercial launches and manned launches of Soyuz spacecraft to the International Space Station. Guiana Space Center. The main European spaceflight complex is located in Guiana, France, on the Atlantic coast of South America. This one is closest to the equator of all the major space launch sites in the world, and Russian Soyuz launchers also use the base to send unmanned cargo. The Guiana Space Center was built by the French Space Agency in 1968. Still, today is largely funded by the European Space Agency. Space travel. To reach Earth's orbit, any spacecraft must overcome the Earth's enormous gravitational force and accelerate with sufficient force for sufficient time to reach speeds of several kilometers per second. Missiles are the only devices currently capable of reaching Earth's orbit and beyond. A missile operates on the principle of action-reaction. In most rockets, two chemicals, a fuel and an oxidizer, combine and ignite in a combustion chamber. When the exhaust gases produced by this combustion reaction come out of the end of the rocket engine, the reaction force causes the rocket to move forward in the opposite direction. The most important manned spacecraft ever orbited by rockets include U.S. space shuttles and Russian Soyuzes. U.S. space shuttles. NASA's Space Shuttle, first flown in 1981, was designed to reduce the cost of spaceflight to Earth orbit. The system consisted of a large orbiter, a huge external fuel tank, and a pair of recoverable auxiliary missiles. This system could be used to put satellites in orbit, retrieve and repair them, and as a laboratory in Earth orbit. But the high cost of the system, as well as 2 catastrophic accidents, paralyzed the mission. In 2010, the space shuttles retired forever. Soyuz story. Soyuz is the main Russian manned spacecraft, which has been used with modifications since the 1960s. It is a multi-part or modular space that resembles the American Gemini and Apollo spacecraft of the 1960s. The spacecraft is launched with the help of Soyuz rockets and consists of various parts, such as the orbiter section, where the astronaut crew spends most of their travel time, a return section to Earth, and a cylindrical section known as the service section. This part of the service includes engines for small maneuvers in space, power supply systems, solar panels, and other equipment. Unlike space shuttles, Soyuzes are not reusable. The service section and orbiters remain in Earth's orbit to burn later in the Earth's atmosphere. The only part that returns to Earth is the return to Earth part. Inside the circuit. It must maintain its position as soon as a spacecraft successfully reaches the space boundary at an altitude of 100 kilometers above the Earth's surface. Achieving a stable orbit around the Earth requires a tool that can reach high speeds that allow it to withstand the Earth's gravity. Therefore, the performance of the last stage of launching a satellite is seriously dependent on the use and destination of that satellite. 8.5 minutes after launch, the Space Shuttle's main orbital engine shuts off, leaving it in near-Earth orbit. At this time, the shuttle is at an altitude of 340 kilometers and is moving at a speed of 28,000 kilometers per hour parallel to the ground. The Earth's gravitational pull entirely offsets the shuttle's tendency to continue moving in a straight line toward space. At this point, the shuttle can place its mobile satellites in near-Earth orbit with the help of its robotic arm. This was a great way to put satellites into near-Earth orbit that were short-lived or that we would meet again later, like the Hubble Space Telescope. After the satellite is launched into space, it more or less remains in orbit. Of course, slight changes occur due to the friction with the upper floors and the thinness of the Earth's atmosphere in the position of the spacecraft or telescope, reducing the height of its orbit. The Hubble Space Telescope, for example, was placed in a higher orbit, and its orbital correction was corrected each time the Space Shuttle met with Hubble to repair Hubble. Satellites that are supposed to go to higher orbits usually do this with the help of small propulsion engines that attach to the fuselage and are known as the cargo assist section. The satellites were launched from a small sloping platform through the shuttle's cargo compartment with the help of these engines and only started when the 2 spacecraft were at a safe distance. Rocket-assisted release. The top layer of any rocket launcher usually consists of an aerodynamic shell called a membrane. Satellites do not have to have their aerodynamic structure. They only have to deal with the slight tension in the extremely thin upper layer of the Earth's atmosphere. However, their fragile structure and appearance cause them to disintegrate due to strong air currents during launch if they are not protected during launch. The lower floors of a rocket are typically designed to drop payloads into low, near-ground orbits, where the rocket membrane separates and exposes its payload. Satellites are usually equipped with small one-stage or two-stage missiles similar to cargo-assisted missiles, to help them enter their proper orbit. With just one ignition of these motors, the satellite can enter the elliptical orbit. Turning on the engine a second time, even for a second, can put the satellite in a higher circular orbit. Space Station supplies. Currently, all manned space travel aims to meet the International Space Station, located at an altitude of 340 kilometers above the Earth. Before the end of their operations, the space shuttles focused mainly on transporting large equipment and tools to the station. This is the case if most of the astronauts are transported by Soyuz. These Soyuzes remain attached to the station body for a few days so that the space crew can change places and the previous crew can return to Earth. 2 Soyuz capsules always remain connected to the station and play the role of the station rescue boat in an emergency. Unmanned spacecrafts, including Russian Progress spacecraft, EU orbiters, Japanese HHS, and, in recent years, Dragon capsules from SpaceX and Cygnus, are responsible for transporting cargo to the space station. In Earth orbit, satellites may be placed in different orbits to carry out their missions. Circuits start from circular circuits close to Earth and extend to elliptical circuits with excessive stretching and orbital deflection. Some satellites also follow a path that may not be Earth's orbit. Still, they are in a position always to maintain the same position relative to our planet. Types of circuits. Satellite orbits in terms of altitude can range from a few hundred kilometers to several thousand kilometers. The laws of gravity dictate that the farther away a satellite is from the Earth, the slower its speed around the Earth. For example, instruments such as space shuttles were placed in near-Earth orbits, orbiting the Earth every 90 minutes. At the same time, satellites in medium orbit at an altitude of about 20,000 kilometers orbit the Earth every 12 hours. At an altitude of 35,786 kilometers above the Earth's surface, satellites orbit the Earth exactly every 23 hours and 56 minutes. The satellite in this orbit always maintains its position relative to the Earth's surface. It is always seen from the ground at a fixed point in the sky. These circuits are known as fixed Earth circuits. Spacecraft in elliptical orbits travel farther from Earth in part of their path, and their speed varies in different parts around the Earth. Orbital inclination, i.e., the angle the satellite's orbital plane makes with the Earth's equator, is another important indicator. Most satellites orbit our planet from the Earth's equator or have a slight deviation from the Earth's equator and only pass over limited and close to the equator latitudes. Orbits with very high deflections, such as polar orbits, allow satellites to reach the top of the polar regions and pass over our planet's entire surface as the Earth orbits itself. The Sun-synchronous orbits slowly change their orbital inclination so that they can always keep the angle between the satellite, the Earth, and the Sun constant. Satellites require different orbits based on their different applications. For example, near-Earth orbits are ideal for satellites that only need to reach beyond the compact part of the Earth's atmosphere. Low-altitude polar satellites are suitable for spy and surveillance satellites that want to cover the entire Earth. Photography and imaging missions use solar-powered orbits. Geostationary orbits allow satellites to remain stationary above a specific point on the equator and monitor a hemisphere. In this case, these circuits are ideal for communication and telecommunication purposes. The orbits, known as molnia, place a satellite at a very high altitude above a point on Earth. The satellite moves in that orbit at a very slow speed and can be suitable for communication at high altitudes. Lagrangian points. There are specific points in the Earth-Moon-Sun system known as Lagrangian points. At these points, widely used properties are created due to the effect of the gravitational force of these objects. The most important of these points are Lagrangian points 1 and 2, located on both sides of the Earth and along the Earth-Sun direction. At these points, the set of forces entering the satellite there causes the satellite to orbit the Sun at the same time as the Earth orbits the Sun. Point L1 is a popular point for placing instruments that are supposed to study and observe the Sun. The Sun Point, or L2, houses space observatories such as the Gaia Observatory, the Herschel Observatory, and WMAP. At point L3, a spacecraft is permanently in front of the Earth and the Sun. Points L4 and L5 are Trojan points of orbit, where spacecraft and various devices can orbit the Sun without disturbing Earth's orbits. Space waste. The several thousand satellites launched so far have generated large amounts of space debris in Earth's orbit. Items range from small pieces and shells detached from paint on rockets to an entire rocket floor. Most of the debris in orbit close to Earth eventually automatically enters the Earth's atmosphere and falls into it. Some satellites and spacecraft are also deliberately and pre-programmed to return to Earth at the end of their lives. But the possibility of active satellites colliding with these fast-moving components is a serious threat growing by the day.